Welcome back to TECHMargadarshi. In part 6, we'll explore some of the most powerful and real world Java concepts, such as super keyword, final keyword, access modifiers, enums, exception handling, and file handling. These topics help you write secure, maintainable, and robust Java applications, and they are very important for interviews as well as real time projects. So let's dive in. Here is the first topic, super keyword. In this slide, we'll understand the super keyword in Java. The super keyword is used to refer to the immediate parent class object in an inheritance relationship. Using super, we can access parent class variables, call parent class methods, and even invoke the parent class constructor. This is especially useful when both parent and child classes have variables or methods with the same name. In short, the super keyword helps us clearly distinguish and reuse parent class behavior inside a child class. Let's understand the super keyword with a simple example. Here, we have a parent class and a child class that extends it. The parent class contains a variable, a constructor, and a method. Inside the child class constructor, we use super dot parenthesis. This calls the parent class constructor first before executing the child constructor. Next, inside the display method, we use super.name to access the variable defined in the parent class. We also use super.show to call the parent class method. So, in short, super helps us access parent class members and avoids confusion when parent and child have similar names. This is especially useful in inheritance scenarios. Now, let's understand the final keyword in Java. The final keyword is used to restrict modification in our program. When we declare a final variable, its value cannot be changed once it is assigned. It behaves like a constant and is commonly used for fixed values such as configuration settings or limits. In this example, the variable max is declared as final and assigned a value of 100. If we try to change this value later, Java will throw a compile time error. So remember, a final variable cannot be reassigned, which helps make your code safer and more predictable. In the next slides, we'll see how final works with methods and classes as well. Now let's understand the remaining uses of the final keyword in Java, final methods, and final classes. First, a final method. When a method is declared as final, it cannot be overridden by any child class. This ensures that the behavior of the method remains the same, even when inheritance is used. Final methods are commonly used when logic is critical for security or consistency. In this example, the show method is marked as final in the parent class, so the child class is not allowed to override it. Next, a final class. When a class is declared as final, it cannot be inherited. This means no other class can extend it. Final classes are used when we want to prevent changes to the class structure. A real world example is the string class in Java. It is final to maintain immutability and security. So remember, final method prevents overriding and final class prevents inheritance. Now let's understand access modifiers in Java, which control the visibility of classes, methods, and variables. Java provides four types of access modifiers: public, protected, default, and private. These modifiers decide who can access a particular class member and from where. First, public members are accessible from anywhere, inside the same class, same package, or even different packages. Next, protected members can be accessed within the same package and also by child classes through inheritance. Then we have default access, which applies when no modifier is used. Such members are accessible only within the same package. Finally, Private members are the most restrictive. They can be accessed only inside the same class. Using access modifiers properly helps us achieve encapsulation, improves security, and makes our code more structured and maintainable. Now let's understand what an enum is in Java. An enum, short for enumeration, is a special data type used to store a fixed set of constant values. Enums make your code more readable and meaningful by replacing hard coded values with named constants. They are type safe, which means Java ensures only valid enum values are used. Enums are commonly used for things like days of the week, months, states, or fixed options in applications. They also work perfectly with switch case statements, making decision making code much cleaner. For example, here we define an enum called day with constants like mon and tue. Instead of using numbers or strings, enums give us clarity, safety, and better maintainability. In this slide, we are looking at a practical example of enum in Java. Here, we have defined an enum called day, which contains a fixed set of constants like Monday, Tuesday, Wednesday, Thursday, and Friday. These values are predefined and cannot be changed at runtime, making enums very safe and reliable. Inside the main method, we assign day.monday to the variable today. This ensures type safety because today can only hold values defined inside the day enum. Next, we use a switch case statement with the enum value. Java enums work seamlessly with switch cases, making the code more readable and structured. When the day is Monday, it prints start of the work week. When it's Friday, it prints end of the work week. For all other days, it prints midweek day. This example clearly shows how enums improve readability, maintainability, and safety compared to using integers or strings. Enums are commonly used for things like days, months, status codes, roles, and directions in real world applications. Now let's understand exception handling in Java. Exception handling is used to manage runtime errors so that the program does not crash unexpectedly. Instead of stopping execution, Java allows us to handle errors gracefully and continue the program flow. In this example, the risky code is placed inside the try block where we attempt to divide a number by 0. This causes an arithmetic exception. The catch block immediately handles this exception and displays a meaningful error message instead of terminating the program. The finally block is always executed, whether an exception occurs or not. It is commonly used for cleanup activities like closing files or releasing resources. As you can see, even after the exception, the program continues to run normally. This is the key advantage of exception handling. It ensures stability, reliability, and smooth execution of Java applications. That brings us to the end of part 6 here on TECHMargadarshi. Today we explored powerful Java concepts like super, final, access modifiers, enum, and exception handling. These topics help you write secure, structured, and maintainable Java code. Make sure to practice these concepts to gain confidence in real world applications. Stay connected with Tech Margadarshi for the next part of our Java learning journey.